Hi everyone, my name is Ram Mudigina. My research proposal is about phishing attacks. So the title of the project is Robust Web Spoof Diagnosis Plugin powered by machine learning and hybrid features with a real-time user experience. So what is a phishing attack? Phishing is a fraudulent attempt to obtain sensitive information such as usernames, passwords, and credit card details by disguising as a trustworthy entity in an electronic communication, typically carried out by email spoofing or instant messaging. It often directs users to enter personal information at a fake website, the look and the feel of which are identical to the legitimate site. Phishing is an example of social engineering techniques being used to deceive users. So what happens here? Attacker creates a fake website which looks identical to the legit site and trick the user into his act sites and perform malicious activities with an intention to steal the sensitive information and money. To the right, I've tried to explain the mechanism of how these attacks are launched. With the help of these attacks, the attacker can create a financial fraud on banking sites or social networking sites or any other websites. He can mob the copyrights and cause the reputation damage. He can launch a huge data breach attack and steal all the sensitive data about the organizations. And the more danger and the more dangerous thing about this kind of attacks are once he is able to launch the attack successfully, he can do things way beyond our imagination. Now let's see how these attacks are launched. There are so many methods or techniques hackers use in launching these kind of attacks. I've tried to explain few here. So these are the most like popular and famous techniques hackers use in launching these kind of attacks. So the first one is injection. So the code injection is the exploitation of a computer bug that is caused by processing invalid data. Injection is used by an attacker to introduce a code into a vulnerable computer program, and change the course of execution. And the next attack is CSRF, which is cross-site request forgery attack. It is also known as one-click attack or session writing, and abbreviated as CSRF or XSRF. It is a malicious exploit of website where unauthorized commands are transmitted from a user that the web application trusts. And the next one is cross-site scripting, which is also known as XSS attack. It is a type of computer security vulnerability typically found in web applications. Cross-site scripting enables attackers to inject client-side scripts into web pages viewed by other users. Using this kind of attacks, the hacker can steal cookies from the web pages. Usually, the session login ID, session tokens, which are stored in the cookies, can help the attacker to steal the data, like user credentials and password or the bank credentials, etc. The next one is DDoS attack, and DDoS means distributed denial of service attack. Uh, it is a type of attack where multiple compromised systems, which are often injected with a Trojan, are used to target a single system, causing a denial of service. Attacker overwhelms the targeted server by sending fake requests with an intention to shut down the entire server. And the next one is SQL injection, which is very famous. It is a code injection technique used to attack data-driven applications in which SQL statements are inserted into an entry field for execution. And the keylogger injection. Attacker tries to retrieve data that is stored in the keyboard. In this attack, he can know what the target is typing while entering the credentials online. So it's a piece of software or a hardware device that logs every key you press on your keyboard. So broken access control technique. Access control, sometimes called authorization, is how a web application grants access to content and functions to some users and not others. So these checks are performed after authentication and govern what authorized users are allowed to do. And by implementing this kind of attack, he can change the parameter value of the referring object, and he can access the unauthorized content which he is not supposed to do. Now let's see the detection approaches. So usually the detection mechanism consists of two models. One is a feature based or content based model, and the other is list based. In the list based, there are two types, which is one is blacklist and the other is whitelist. The suspicious domain is compared with the designed database that contains suspicious domains. They are called blacklist database. And in whitelist database, uh, all the legitimate sites are stored and they are compared against uh, user searched URLs, websites or web pages. So, but the problem with this kind of approach is it cannot detect the new fraud website because of the delay caused due to the database update time, and a very high percentage of fake URLs are subjected to a update in the blacklist every 12 hours, and that shows the seriousness of this issue. In the content based or the heuristic based detection, the spoof sites are compared with the attributes of the website against the predefined rules like URL detection, domain names, originality check, and IP address, visual similarities, page layout attributes, etc. and etc. Since these attacks are highly sophisticated, this approach may not serve the purpose to full extent. Most of the papers based on this approach showed a high false positive rate, which is not a good thing. So the content based comes under this category. In this slide, we are going to talk about literature review that has been done on this kind of attacks over the past few years. Like I said in the previous slide, there are two kinds of approaches in detecting these kind of attacks. One is list based. It could be either whitelist or blacklist, depends on the website status. And the other one is heuristic based or the content based, where the attributes of the websites are taken into consideration and then they are compared against the legitimate sites attributes, and based on the result the status of the website is delivered. So first we'll see the blacklist. So blacklist approach contains all information about phishing sites. So phishing sites are not legitimate or they're all fake. So blacklists, usually the internet browsers like Mozilla Firefox or Google Chrome, they use this kind of approach in detecting phishing sites. The problem with these sites is that it cannot detect 0-day attacks, and the more dynamic approach in detecting the new fish sites, it lacks in this kind of approaches. And the whitelist database are a set of trusted sites and are compared with the user requested site. The problem with this approach is almost all sites users are new and dynamic. So users might be restricted from accessing the new legitimate site which is not present in the database. It could be legitimate, but since it's not present in the database, it reports the site as a phishing site. But in real, it could be a legitimate site. So that's a problem with this kind of approaches. So these both approaches are good to a certain limit, and it cannot eradicate the problem entirely. And the next one is heuristic based or the content based. So this kind of approaches are very famous and very popular. Most of the research was done based on these kind of approaches. So the first technique is goldfish technique. It used the attributes of page elements, and they classify the author tried to classify the page as a legit or not based on the page elements. HTML source code and the content of the URL features are also considered in this approach. It gave a 16.9% false negative rate with a 0.4% of false positive rate. And there was another technique using the URL features along with Google PageRank to decide site status. Since most of the phishing sites are new, they don't have a high page rank, and based on the decision is made in this approach. And 4.2% false negative rate and 1.2% false positive rate was recorded in this approach. There's another method, other technique, where the keywords are retrieved from the DOM properties, and by using the natural language processing techniques, a method was proposed by Xian. It gave a false positive rate of 29% and false negative rate of 12%. And there's this cantina technique which is very popular and very efficient technique. It used a lexical signature of TF, IDF algorithm, and a domain age and suspicious links as a heuristic in this approach. So the next approach is multi-tier approach. It is used in email filtering. In this approach, the algorithms were rescheduled between the tires. It has three tires. The best low false positive rate is recorded in this approach. Classifiers, they process the email messages independently. So since like even though if one tire is completely shut down, there are other compartments which can operate on their own. So optimum accuracy can be achieved even though one classifier at the core is shuts down, which is a good thing about this approach. And the other approach is associate classification technique. It uses URL features, domain features, security and encryption features in deciding the website status. Page content and social features which are used in this approach showed a great influence in detection rates. And the problem with the text-based approaches is that they can be easily morphed or manipulated by the attacker by hiding the text with an image or replacing the text with an invisible text. So to overcome this problem, there was this approach called EMG-based visual similarity assessment approach. It used pixel level of web pages instead of text. But the problem with this approach is it left the source code entirely. Even though efficiency of the computation is improved and the accuracy is improved, leaving the source code entirely is not a good thing to do. There was another thing called SVM classifier approach, where the structural properties of the email are taken into consideration in deciding the phishing status of the website. But this model lacks machine learning abilities. So the algorithms used in this approach are outdated and very slow, and they're not at all good in classifying the data. And the data set considered is very large, in these kind of attacks. So to classify that huge amount of data, we need a strong algorithms, and this approach lacks that. And the other approach, again, a visual approach, transforms the web pages to blocks based on the visual properties. The approach they used here is they used blocks instead of the normal approach. So since using the block approach and doing that, they have achieved a great accuracy. But the problem with this approach is, again, the algorithms used in this approach is very outdated and very slow. And there was a framework to detect the phishing websites by the characteristics of URLs is proposed. But the good thing about this approach is the logistic regression algorithm which they used. It gave a very good accuracy rate in detecting phishing attacks. So in this slide, I'm going to explain the evaluation metrics. So how the calculations are done. So there's a few terminology we should be aware of. The first thing is true negative rate. So what is true negative rate? It defines the count of instances where the website is correctly detected as legitimate. And the false negative rate defines the count of instances where the phishing website is incorrectly detected as legitimate. The position is equal to the correctly detected attacks value over all the websites identified as phishing. As you can see, all the equations are shown here, and this is F1 score, which is the harmonic mean between the position and R. So the accuracy measures the overall rate of correctly detected phishing and legitimate instances, and the weighted error is the overall weighted rate of incorrectly detected phishing and legitimate instances. All the terminology is explained in this slide. So WLP means the number of instances legit sites are detected as a phishing site. WLL means number of instances legit site detected as a legit site. WPL means the number of instances a phished site detected as a legit site. WPP means number of instances a phished site detected as a phished site. And the lambda gives the weight of number of legit instances count. So here is a design proposed by me. As you can see to your left, this is the main block. This is the main design of the entire project. There will be a data set and a machine learning algorithms and a simulator and an alert mechanism. So what happens here? Data set is fed with a lot of information by extracting the features For example, CSS rules of the web page is extracted from CSS extractor, and the rules are exported to the external style sheets. DOM removes the structure of pages, body, and visibility attributes of every page element. Filter delete the information gathered from all the extractors, and the less significant features are excluded from the program. Rest of the rules will be converted as a signature of a low image resolution and is sent to the simulator by using all the machine learning algorithms. So after the whole data is sent to the simulator, so the data classification is performed in the simulator. Simulator compares the originality report between two pages, looks for the similarity value. If it's beyond the threshold value, it reports it as a fake page. But the heart of the entire design is the dataset. And the dataset here contains three important parts. One is content dataset, visual dataset, and list-based dataset. Since as explained in the previous slides, all the approaches are limited to one kind of approach, either content based or the visual based or list based. So what I'm trying to do here is I'm taking into consideration all the significant features which have an impact in detecting the phishing sites. So in this proposal, I took all the features which are very significant in detecting the phishing models from the content data, from the visual data, and from list-based data sets. So in this approach, all the content visual list-based approaches are applied and incorporated into a whole new data set. In this design, new features are taken into consideration other than the traditional URL and domain features which have been researched in the past. And I will be explaining all the new features which I am taking into consideration in the next coming slides. The literature review has shown that visual approach yields more success compared to other traditional approaches. Page layout analysis is considered in extracting important visual similarity features. So various features like URL features, hosting domain features, site popularity features, page layout features, CSS layout features, keywords are extracted from the both benign and phishing websites. So, and a Python application extracts these features from the input files and stores results as a CSV file. And the URL is split into domain name, path, and TLD portions based on token system. These tokens are clubbed together as a big word vector. Python libraries URL parse pulls the domain name and the HTTP scheme of the URL, IP address, IP prefix, and autonomous system number information, SOA record details, along with DNS records, which are obtained as a JSON object from IP who is Python module. So WOT feature is extracted from WOT API module, and the page rank features are extracted from Celob Python module. These features are extracted and they are in binary values. In theory, this methodology has the potential to detect different types of phishing attack like spear phishing, whale phishing, and including zero-day attacks. To make it more feasible, the whole data is converted into a low resolution image which will enhance the computational power of the algorithms. And the classification is done at a block level and it is distributed among different blocks in the simulator, which is an essential factor in this paper. Over the past few years, there were so many algorithms used by the researchers, but none of the algorithms were sufficient or efficient enough to detect the phishing attack to the full extent. So in this paper, I've chosen gradient boosting algorithm, which was never used before by any researcher. So there's no single paper used this algorithm before in phishing detection. It works on numeric values only. In this model, many groups are assembled in predicting the outcome. Bagging and boosting are two basic steps in this algorithm. Bagging means grouping different models together and their weights are adjusted accordingly. This method works on error reduction sequentially. The basic idea of the algorithm is to make a strong model by grouping the weaker models in the dataset. This is called boosting. So the approach minimizes the errors and provides stronger models for classification and prediction of the outcome. For the classification of data, gradient boosting algorithm is considered due to its prevention of data loss. We get with this algorithm, by using this kind of algorithm, we can prevent the data loss the most. Gradient boosting is like a simple linear regression model. It leverages the pattern in residuals and strengthens a weak prediction model until residuals are randomly distributed and then stops modeling residuals. The accuracy of the classification model will be high when it meets the requirements. Decision tables, logistic regression algorithms, robust gradient boosting, J48, naive Bayes classifiers are also used to build the classification model in this proposal. This model tokenizes the text and converts into a binary feature vector. So here are the features that are taken into consideration for this proposal. URL features like age of domain, known images, suspicious URLs, suspicious links, IP addresses, dots in the URL, URL redirects, tokens in your URL, length of the URL, presence of the character codes, forms, visual layout check, CSS styling and page layout analysis, and TLD organization. And under page and JavaScript features, HTTP header information, HTML code and images, presence of page events, abnormalities in the script, and white spaces, hidden elements, unknown tags, presence of specific page fields, and a request URL, requests of hyperlinks, etc. Under hosting domain, all the information related to the domain features are taken into consideration, like DNS record, DNS IP address, hosting domain features, etc. Under site popularity features, I took page rank and website traffic. Links pointing to the site from the search engine are also taken into consideration, which is a new thing. Very few others have taken site popularity features into consideration, and I have added 2 3 features more into my proposal. And security and network features, so like SSL features and abnormal cookies, public key certificates, TCP information, application layer features, DNS queries, traffic flow, and etc. are considered under this security and network features. And like I said, visual features are very important and they give more accuracy and more efficiency to the model. So under visual features, CSS feature extraction, DOM extractor are taken into consideration. So these are the features which I took into consideration, and I will be adding more features once the project is started. Although numerous anti-phishing techniques exist, no single approach can address all the type of attacks. Importantly, zero-day attacks, or embedded object attack, or DNS poisoning attack, etc. Attackers come up with a new kind of technique or new kind of method in launching these kind of attacks. So it gives researchers the most work. Whenever the hacker comes up with something, the researchers should match that level. Most of the approaches could not detect zero phishing attack due to the dynamic nature of the attack. So therefore, detection of zero-hour phishing attack with high efficiency is still to be researched. And worldwide websites use different languages, and the layout of those sites is identical. Heuristics uses the keywords which are language dependent. They report the attack based on the similarity of the heuristics of the phished page. However, this approach cannot detect zero-hour attack since the database should be updated to compare the spoofed site with the original one. And attackers use images, JavaScript, etc. to enter the network. As we discussed, image processing base detects suspicious web page content that is replaced by text or image by an attacker. In this method, a snapshot of the web page is compared with the database. This consumes a lot of time to compare numerous suspicious websites, hence this approach is also not good. The threshold represents the similarity level between the two sites. So setting up the right threshold level is a vital and important aspect in any model. When the phishing website is 50% copied from the legitimate site, no visual similarity based approach that exists today can detect the attack. Therefore, an appropriate threshold is a challenging task. So to conclude the whole thing, an ideal phishing detection method should maintain both false negative and false positive rate as low as possible. And in my proposal, I'm trying to address the most uh, the most important attacks: zero-day attacks, an embedded object attack, and DNS poisoning attack. So I try to come up with a solution to detect these kind of attacks in a efficient way. And I'm trying to implement the whole project as a plugin in a web browser, like Mozilla or Google Chrome. I'm trying to embed the whole concept, the whole idea into the web page, into the in the web browsers as a plugin, so that it can be used in real time by the user. So that's all for now. Thank you.